Hola, buenas tardes a todos amigos. ¿Qué tal? Soy Plácido Doménech y hoy tenemos un nuevo programa en xHUB.AI, un nuevo Inside X que parece que tanto están gustando. En este caso, dedicado a Yann LeCun. Sabéis que en los Inside X que estamos haciendo, al menos en los de las 3, voy a intentar analizar tanto temas como personas diferentes cada programa. Intentar no repetir, aunque creo que con Demis Hassabis repetimos. Pero bueno, dada la importancia del personaje, si sale Ilya Suskever también repetiríamos. Y hoy toca Yann LeCun. Yann LeCun, donde vamos a analizar por partida doble, bueno, un vídeo bastante extenso, ahora lo veremos, donde Yann LeCun va a explicar su propuesta de arquitectura para llegar a la inteligencia a nivel humano o nivel humana, o inteligencia humana, cómo alcanzar la AGI en definitiva, la famosa arquitectura GEPA, se pronuncia. Y ayer, además, aprovecharemos, luego lo veremos, la noticia del lanzamiento de xHUB.AI, es decir, ya partes de esta arquitectura en diferentes versiones que van a utilizarse en diferentes ámbitos, incluido el tema de la robótica. No va a ser un artículo de xHUB.AI, aunque luego veremos la web. Vamos a centrarnos en 2 charlas, una donde se explica XHEPA, que dura casi 1 hora y 20 minutos, y luego un pequeño corte de 10-15 minutos de un podcast, de una intervención de Yann LeCun reciente, donde comenta que los LLMs no son el camino para llegar a la AGI, que no estamos a 2 años de la AGI, y explicará un poco por qué. No lo he visto, no he visto ninguno de los 2 vídeos. Bueno, vi uno parecido al de XHEPA, no este último que es más reciente porque ha ido actualizando, pero bueno, vamos a ver todo esto juntos en tiempo real. Y antes, bueno, ir saludando a la gente del chat, que normalmente estos programas de Inside X, como sabéis, sirven para que todo lo que digáis en el chat lo lea, lo siga, lo conteste, responda. Y luego las charlas no es que pongamos la charla y ya está, sino que, bueno, iré parando o diciendo cosas si quiero decirlas. Con lo que entonces a lo mejor, pues 2 horas que va a ser casi de intervención de Yann LeCun, pues se van a convertir en 4, no lo sé. No he traído agua, bueno, iré luego por bebida. Hace muchísimo calor. Se me ha roto nada, para que no pase el calor voy a necesitar una catástrofe. Dirige y presenta el programa Plácido, Doménech, Espí, vuestro amigo, que estamos teniendo además una muy buena acogida. Bueno, la verdad es que es constante, ¿no? Y aunque llevamos 5 años y no quiero mirar atrás, es cierto que la comunidad y el impacto del canal está teniendo mucho reconocimiento, cosa que estoy muy contento, tanto por mí, por toda la gente que interviene, por todo el equipo. Esto no acaba más que empezar, esperamos cada vez hacerlo mejor. El único problema es que los días tienen 24 horas y solo hay 7 en la semana. Y eso es un gran problema de momento. Bueno, hay otros también, pero entonces, bueno, la comunidad de xHUB.AI, comunidad de inteligencia artificial, ciencias transversales de habla hispana, xHUB.AI, 5ª temporada. Ya llevamos 105 programas, que por cierto, en 105 programas en la temporada 5. Bueno, no soy muy consciente tampoco de ello. Si no pasa nada o no me pasa nada. Y que, bueno, hubo un pequeño descanso. Bueno, es verdad que en la temporada 5, bueno, no cuenta como memoria, pero hubo ahí un pequeño parón, es verdad. De una semana o 2, no me acuerdo. Y aún así, 105 programas. No pasa nada. De momento no os preocupéis. Tenéis xHUB.AI. Y lo que os digo, estamos empezando prácticamente. El programa está emitiéndose por X, YouTube, LinkedIn, Twitch, Facebook, TikTok, Rumble y Instagram. Y de novedad, Kik. Pero bueno, por no repetirme, TikTok estamos baneados o bloqueados, no sé qué pasa. Y en Instagram la plataforma Restream está teniendo problemas. Así que bueno, tendréis que vernos por alguna de las otras plataformas, pero salimos por un montón de sitios, ¿no? Y si os gusta lo que veis, pues poner me gusta, compartir, comentar, sobre todo lo de los comentarios. Bueno, ya lo he comentado en los otros Inside X, que la cantidad de mensajes ya que recibimos en el chat empieza a ser ingestionable. Incluso en algunos comentarios ya en podcast los contesto todos de momento, pero bueno, si alguien No contesto un mail o un mensaje que sea pesado, porque no es por no contestar, vamos. Es un poco porque está ya el tema desbordándose, cosa que es muy positiva. Suscribíos también al canal y lo importante, que esto siempre ocurre, crece muy poco a poco, evidentemente, pues somos casi creo que 500 miembros, pero siempre recibimos 2 o 3 incorporaciones al día. Este año es tremendo, a ver si podemos llegar a 1000. Bueno, estamos en 500, bueno, no sé si llegaremos a 1000 a final de año, pero bueno. Si queréis uniros a la comunidad de Discord en xHUB.AI, me enviáis un correo o un mensaje directo o un correo por redes sociales o en los podcasts y os paso el enlace y podéis entrar. Si tenéis cualquier problema, me lo comentáis. A ver, voy leyendo los mensajes del chat, que sabéis que los voy a leer todos. En los Inside X los leo todos. Dice J. Bellido que estamos acostumbrados a los programas de xHUB, que no hay problema ya, ¿es verdad? Yo me acuerdo, bueno, sigue siendo mi amiga. Al principio presentaba los programas con Julia Dibroska. Desde aquí un saludo y me acuerdo que decía, yo con 20 minutos, 20 minutos hablando ya no te aguanto, en el sentido de que, bueno, es cierto, ¿no? Bueno, mucha gente está acostumbrada a otro tipo de contenidos, otro tipo de duración, otro tipo de formato, un tipo de explicaciones más rápidas, contenidos más rápidos, píldoras. Nunca ha sido el formato de xHUB.AI y estamos en la 5ª temporada, así que es cierto, también tengo que decirlo, haciendo abogado del diablo, que el impacto en la audiencia más joven es mínimo. Es decir, que es verdad que tenemos un rango de edades en que triunfamos, de generaciones, y del 18 a 25 nos cuesta, ¿vale? Bueno, no sé, ahora estamos publicando también TikToks, pero habrá que hacer algo para también atraer este tipo de audiencia, ¿no? Tan importante de 18 a 25, fundamental. Guillermo Brand, siendo importante comparar la evolución de la IA teniendo como referencia la inteligencia humana, cabe esperar que la IA desarrolle capacidades intelectuales inéditas. Ya lo está haciendo. Ya está haciéndolo y evidentemente nos superará. Ya lo hace también. En algunos aspectos, ¿no? O en muchos aspectos. Pero sí, bueno, seguimos teniendo... Porque como inteligencia artificial general, o como inteligencia general, hay unas cualidades dentro del ser humano que lo tenemos como referencia. Es la única entidad o especie que identificamos que tiene esas cualidades, ¿no? Esto también daría para debate. Entonces, como referencia tenemos la inteligencia humana, ¿no? Pero está claro que la inteligencia artificial, cuando supere ciertos umbrales, bueno, yo creo que nos va a superar en cuanto a capacidades cognitivas. Va a pasar como un rodillo por encima, vamos. ¿Qué pasará entonces? Bueno, ya veremos si nos hibridamos o cuál es nuestro rol. Ya lo veremos. Lo que sí es verdad, dice MMBBAA, lo que sí es verdad es que hay un montón de documentación y acceso a formación en forma de enlaces al menos. ¿Habéis pensado en una landing page? No, hemos pensado no en una landing page, en una web, en una plataforma que permita acceder a toda esa información de una forma más inteligente, utilizando IA, etcétera. Pero, claro, el problema de todo eso es la monetización. Pero bueno, también si no la tienes no puedes monetizar. Entonces, ahí estoy. O bueno, ahí estamos, no estoy tampoco yo solo. Esto de la AGI sería alerta asiento. Esto de la AGI sería como sacar la universidad estando en los colegios a los 20 años libres, sin profesores ni jefes. Y Alberto, Plácido, ¿has pensado en quitar la imagen de TikTok cada vez que dices por los medios que se emiten los programas? Lo digo porque si no emites por TikTok, ¿para qué quieres tenerlo? No, hombre, porque en principio sí que se emite. Si veo que pasa mucho tiempo, pues al final lo quitaré. Pero bueno, en principio la idea es recuperar TikTok. Si no, pues lo quitaré. Pero prefiero tenerlo y recuperarlo, aunque pase un año, que no quitarlo, ponerlo, quitarlo, ponerlo, quitarlo, ponerlo. Si te ha gustado lo que habéis visto, pues apoyar económicamente el canal podéis a través de enviar un café, Buy Me a Coffee, o compráis un café, un helado, que nos lo merecemos, me lo merezco, o un PayPal a través de Plácido. Recibimos, la verdad, muy poco apoyo económico en ese sentido, nulo, casi diría, para que os voy a negar, aunque siempre recibimos alguna alegría, eso también. Estaba pensando incluso este mediodía que quería haber publicado 3 podcasts y no me ha dado tiempo, porque bueno, trabajo, preparar programas, 1000 cosas, aprender, programas, bueno, 1000 historias, ¿no? Y claro, más que el podcast, ronda mi cabeza si el podcast pasarlo de pago. Pero el objetivo de xHUB.AI es visibilizar al máximo este tipo de contenidos. El problema es que, es cierto, el apoyo económico es nulo, ¿no? Tampoco quiero cada uno que haga lo que quiera, pero claro, si no eres capaz de pagar ni 3 euros al mes, 3 euros de programas que escuchas horas, claro, entonces eso es un problema, porque ya no es que alguien te lo pague, sino que si estamos hablando que el podcast, o sobre todo podcast, el podcast es una auténtica locura y YouTube no somos capaces de monetizarlo, pues claro, el trabajo que lleva es que son 3 euros por persona. La gente no paga. La gente, yo tengo claro que no paga por contenidos. Entonces, estoy pensando qué se puede hacer para monetizar. Vender cursos a 1.500 euros, a 2.000 euros o a 3.000, no lo sé. Algo habrá que hacer, ¿de acuerdo? Porque es verdad que lleva todo muchísimo trabajo. Al revés, lo que buscamos es incluso, con todo el tema de generación de vídeo, etcétera, hacer el canal aún más pro, mejorar todo, calidad, sets, más cantidad de contenido, pero claro, recursos, tiempo, dinero, ¿no? No os quiero llorar, pero también estamos aquí para hablar de la realidad. Y es interesante también hablar de la realidad de xHUB.AI. Estamos también hablando con la posibilidad de ampliar xHUB.AI a Latinoamérica para ampliar y mejorar audiencia, impacto y sinergias, pero bueno, veremos, os iré contando. También anunciaros que mi charla, sabéis que tengo una charla que superó, llega a torno a las 300.000 reproducciones, una charla de las más vistas sobre inteligencia artificial, cosa que es una auténtica pasada, ¿no? En el canal de Inversión Racional tenéis esa charla que está entre las más vistas y vamos a hacer la round 2. La ronda 2 se grabará el programa en julio y se emitirá en agosto, con lo que, bueno, yo sé que esta charla además generó que mucha gente me conociera, así que estoy convencido que mucha gente estará muy contenta de volver al canal de Inversión Racional y pues hacer una charla sobre todo lo que rodea a la inteligencia artificial. No tenemos Patreon, hay PayPal. Si os suscribís a iVoox podéis hacer una suscripción y Buy Me a Coffee, que es parecido a Patreon. Puedes decirle 5 euros o cada mes de 5 euros. Es muy parecido a Patreon. Vi varias posibilidades como Patreon y otras plataformas, ¿vale? Pero yo tengo en la cabeza hacer una plataforma independiente de contenidos y de pago. Y no depender de YouTube ni de ninguna plataforma que nos censuren. Pero requeriría pues mucha inversión y pues de momento hay que ver. Pero mi intención o visualización de lo que a mí me gustaría y querría es un canal tipo Netflix, tipo Gaia, tipo unos canales, no me acuerdo cómo se llama, Valley, no me acuerdo. Bueno, canales que integran su propio contenido, ¿de acuerdo? Tienen su propia aplicación, etcétera. Pagas una cuota y se acabó. Pero es complicado de momento. Es complicado porque eso requeriría que los contenidos fueran más trabajados en producción, tendría que haber un equipo, costes de desarrollo, pero es verdad que el trabajo es enorme y tiene que compensar. Y no tiene que ser 10, ni 20, ni 100 personas, tiene que ser miles las que aporten 1 euro, 2, y es lo que hace que puedas mover recursos, equipo, gente, para hacer cosas a otro nivel. Pero bueno, yo creo que en 5 años estamos haciendo un buen trabajo. como mínimo quedarnos igual y disfrutarlo, sobre todo disfrutarlo. El día que no lo disfrute, bueno, también darle un enfoque, también la idea es que xHUB.AI sea una comunidad de pleno derecho y que, bueno, también en ese sentido, bueno, dependa o esté dirigida por mí, pero puede ser también continuar en un futuro si yo estuviera o no, en otra forma, no lo sé. Pero bueno, eso es un poco la visión con la que surgió xHUB.AI. Y aquí estamos, llevamos 5 años, no sabemos cómo van a fluir las cosas, pero hay muchas cosas en mente. De todas formas, todo lo que nos podáis comentar en este sentido, súper guay. Y sobre el programa de hoy, Inteligencia Nivel Humano, Cómo alcanzar la AGI. Bueno, aquí tenéis una imagen que resume lo que es la arquitectura JEPA, que seguramente la veremos en la charla. Un concepto o arquitectura cognitiva donde pues tenemos varias piezas que no existen evidentemente en los modelos de lenguaje, quizás sí en arquitecturas de agentes, pero no exactamente, evidentemente con conceptos de memoria o el tema de la percepción y la actuación, pero bueno, todo lo que es diferentes conceptos como el modelo del mundo, etcétera, configuran una arquitectura JEPA, que es una arquitectura, yo llamaría cognitiva, o una arquitectura de inteligencia artificial enfocada a alcanzar esos niveles de inteligencia humana, ¿no? César Vidal se tuvo que ir completamente a su propia plataforma por la censura. Ya, es que eso es lo que pienso. Es que, bueno, no... A ver, la vida a mí nunca me ha gustado llorar, ¿no? Pero es insoportable, vamos a ver, tío. Es que es verdad. Es insoportable. Yo porque tengo, mira, simplemente no puedo ni promocionar algunos... El 90% de los vídeos de xHUB.AI están vetados. Y es imposible, es que el de ciberseguridad, es que no se puede comentar nada. Tiene que ser un programa totalmente limpio para que no te lo bloqueen. Y la audiencia que te ponen es siempre la misma. Si os fijáis, menos algún programa que pega un pico, te lo tienen todo controlado. Está todo súper controlado. Entonces no es un entorno libre. Y luego el beneficio es para ellos. Yo a veces pongo monetización en YouTube, que la volví a activar, que es un coñazo para la gente. Porque entonces esa monetización se la lleva YouTube. A ti te dan 5 euros o 1 euro. O, ¿eso qué supone? Ellos se hacen millonarios. Tener este contenido en sus plataformas es lo que les da valor. Y tú llevas, nada, ya sé que ellos tienen la infraestructura, los servicios, te dan todo. Ya, pero los que generan contenido somos nosotros. Luego lo mismo, en un clack, pum, toda toma por culo. Ya, ¿cómo que haces así todo se va a la mierda? ¿Perdona? Bueno, a mí no me ha pasado aún, pero es que ahora a mí me dicen, no, es que han tumbado el canal de xHUB porque había una denuncia de no sé qué, ¿no? Y te quedas con cara de gilipollas. Y todo lo que has invertido, tu tiempo, seguidores, canal, contenido. ¿Perdona? Entonces, como sé que ese punto puede llegar porque somos un canal con ese perfil, yo creo que la mejor solución sería crear una plataforma. Y luego en YouTube, pues a lo mejor transmitir algún tipo de contenido o clips, pero el contenido principal y fuerte estará en un canal aparte, una plataforma aparte. Daniel CL, allí patos, vamos, que ya está aquí, me la quitan de las manos. Bueno, y luego, si no os habéis enterado, pues han sacado, vamos a ver la página, no vamos a ver la noticia entera ni analizarla, pero sí que quiero que veáis la noticia, ¿de acuerdo? Pues está muy curioso lo que es porque quiero que entendáis que lo que vamos a hablar pues es muy actual. Ayer presentaron xHUB.2, que es un modelo self-supervised, no supervisado, ¿de acuerdo? Donde crea o recrea un modelo del mundo, a esa parte. Es decir, no es todo el JEPA entero, es la parte visual donde se genera un modelo del mundo, ¿de acuerdo? Pero, bueno, ahí podéis bajar incluso el modelo, probarlo, aprender más, leer el paper. Y aquí estamos hablando de un nuevo nivel de aprendizaje en cuanto a la percepción de vídeo o la simulación de qué estados son los que ocurrirían si haces algo, ¿no? A ver, pues si cierro el frigorífico pasa esto, es decir, un poco cómo funcionan los humanos, ¿no? Otro nivel, nada que ver con modelos de lenguaje, otro nivel, ¿vale? Aquí tenéis, bueno, para todo el tema de robótica, lo mismo. Otro, a ver, está viéndose muy pequeñito, ¿no? Voy a ampliarlo un poco, perdonad. A ver, vale. Vale, entonces, bueno, van por la versión 2, están construyéndolo. Y nada. Lo que vamos a ver es, pues esto es una pieza, una de las piezas, ¿de acuerdo? Lo presentaron ayer, es un modelo de visión para trabajar con modelos del mundo. Un modelo no supervisado, se puede aplicar robótica, conducción autónoma, hecho por Meta, lo van a meter en todos los sitios. Sale el tema de la robótica, el tema de conducción autónoma, asistentes integrados. Y bueno, aquí tenéis paper, etcétera. Bueno, no vamos a ver presentar en su momento XHUB.AI 1, ya lo han presentado XHUB.AI 2, que parece que está muchísimo mejor, ¿no? Y bueno.
AI is a technological challenge as well as a scientific challenge because we don't know how to build truly intelligent systems yet. It's one of the big scientific questions of our time. What's the universe made of? What is life all about? How does the brain work? Or what is intelligence really? Hi everyone, my name is Yann LeCun. I'm the chief AI scientist at Meta. As humans, we think that language is very important for intelligence. But in fact, it's not the case. Imagine a cube floating in the air in front of you, and imagine rotating that cube by 90 degrees. You can sort of picture this in your mind, and this has nothing to do with language. Humans and animals navigate the world by building mental models of reality. What if AI could develop this kind of common sense? An ability to make predictions of what's going to happen in some sort of abstract representation space. We call this concept a world model. Allowing machines to understand the physical world is very different from allowing to understand language. A world model is like an abstract digital twin of reality that an AI can reference to understand the world and predict consequences of its action, and therefore it would be able to plan a course of action to accomplish a given task. It does not need millions of trials to learn something new because the world model provides a fundamental understanding of how the world works. The impact of AI that can reason and plan using world models would be vast. Imagine assistive technology that helps people with visual impairment. AI agents in mixed reality could provide guidance through complex tasks, making education more personalized. Imagine an AI coding agent that can actually understand how a new line of code will change the state of the variable of the program, the effect on the external world in the context of existing code. And of course, world models are essential for autonomous systems like self-driving cars and robots. In fact, we believe world models will usher a new era for robotics, enabling real-world AI agents to help with chores and physical tasks without needing astronomical amounts of robotic training data. This is a very exciting time for AI research and a captivating set of scientific questions in front of us. We want to understand intelligence itself, as well as learning, reasoning, understanding the physical world, so we can build systems that can help billions in their daily lives. We're excited to announce the release of Video XHUB.AI version 2, the next step in this journey. Stay with us as we continue exploring the possibilities of world models and push the boundaries of AI research.
Bueno, pues ya hemos visto esa noticia, lo tenéis en la página web, podéis investigar más, ya veremos si hacemos más información al respecto. Es interesante, sería interesante hacer un Inside X incluso profundizando en la arquitectura y todo lo que va saliendo, pero vamos a ver, yo creo que hoy casi sería como una introducción, una presentación, ¿no? Vamos a ver estas dos charlas juntos, bueno, una charla y un clip de un podcast que es de 1 hora, pero vamos a ver solo ese clip. Vamos a analizar esa primera lectura en la Universidad de Columbia, donde Yann LeCun hace una ponencia titulada Cómo las máquinas podrían alcanzar el nivel de inteligencia humana, ¿no? Y luego, que es de hace 7 meses, bastante reciente, pero bueno. Y la otra sí que es muy reciente, hace unos 10 días, 12 días concretamente, y es, dice lo que ha dicho en varias conferencias. Está la más reciente, en la que dice que no vamos a llegar a la AGI a través de escalar los LLMs, ¿no? Entonces, bueno, vamos a empezar con la primera que dura 1 hora y 20, va a ser larguito, y luego otra cortita de 15 minutos. Vamos, bueno, ir comentando si queréis en el chat. Ahora, mientras, porque no lo tenía, hoy he tardado un poquito más, porque es que no me da la vida, es que no me da tiempo ni para comer. Entonces, bueno, pues... Bueno, la charla tengo que decir que es de un alto contenido técnico. Sé que hay cosas, incluido yo, que no vamos a entender o llegar a entender en profundidad, pero es una explicación por parte de Yann LeCun de este concepto, que además sabéis, ¿no?, que el tema del paper este famoso de Apple, las IAs no razonan, ¿no? Que por cierto ayer vi, mientras hacía otra cosa, un análisis por parte de un influencer ahí y bueno, what the fuck, instrumentalistas, ¿no? Bueno, yo más diría nihilistas, tanto de lo humano como de la inteligencia artificial, pero no voy a entrar en ninguna guerra, más allá de lo que acabo de decir. Y ese análisis o paper de Apple diciendo que no pueden razonar, vamos a hacer un programa la semana que viene que es Apple no razona, la inteligencia artificial y la inteligencia artificial, donde traeremos a varios talentos de, bueno, no sé, lo de expertos es que esa palabra no tiene sentido. Creo que vendrá Samuel Olivares, a lo mejor viene Abel Losada, bueno, 3 o 4 de los habituales de xHUB.AI a nivel técnico y analizaremos si las IAs razonan, ¿vale? Y también analizaremos ese paper de Apple. Vamos a ver bueno, antes ver el chat para por el directo. Que no, dice, buenas a todos, hace tiempo que no me pasaba por el directo. Trolling Stones. Trolling Stones. El podcast en agosto. Ya sé que lo he anunciado muy anticipadamente. Le pedí permiso a José Luis, creo que se llama, presentador, no me acuerdo. Y le dije, quiero anunciarlo. Vamos a grabarlo creo el 19 de julio, pero saldrá en agosto. A principios de agosto. Vamos, lo que pasa es que quería darle bombo, porque fue una charla que tuvo mucho impacto, ¿no? También es verdad que esa semana, que además tengo una ponencia aquí en Alicante, que podéis venir, aún no está anunciada, pero es el 16 de julio. Hay una ponencia que daré de 3 horas de Agentic.AI en Punta Piedra, en Alicante. Es presencial, pero es gratuito. Entonces esa semana no sé si habrán programas o me lo tomaré en plan zen para preparar tanto el evento de Cámara de Comercio en Alicante como la participación en inversión racional. Eso de Apple precisamente lo han criticado muchos youtubers ya, pero yo es que el nivel os tengo que decir que es muy, muy bajo. Y ya mezclan churras con merinas y ya cuando llega la interpretación personal, yo es que me echa para atrás, no lo siguiente. De tardeo. Por LinkedIn sobre Nvidia y Deep Robotics. Morcillete. ¿Pero quién eres, Morcillete? ¿Cuál es tu nombre? Entiendo que en LinkedIn no te llamarás Morcillete. Revienta cerebros. Dice ya, sí, la verdad es que la charla estuvo bien. Porque es verdad que a mí, bueno, son diferentes. A ver, me podéis ver en programas en el que estoy yo solo, programas que entrevisto, aunque no son entrevistas, yo sé que interrumpen mucho. Esto es ya lo típico. En debates, pero pocos en que se me entrevista a mí, ¿no? Entonces, bueno, a lo mejor funcionó bien cuando se me entrevista. Plácido, deberías de decirle a los contertulios que traes que dicen que los programas piloto de review no han sido satisfactorios, que están mintiendo y que no tienen ni idea sobre el tema. Alberto, creo que el que no tienes ni idea eres tú. Pásame lo que acabas de decir por LinkedIn. Pásame pilotos donde se diga que ha triunfado. Porque todo, aunque hayan titulares que digan eso, hay que leer la letra pequeña. Cuando hemos preparado programas, los he preparado yo, normalmente te puedo decir, busca los de Google y los de OpenAI. Busca los de Alemania. Es que, y analiza. No simplemente te quedes con el titular de lo que te quiere decir a alguien. Sergi Martín. Pues no me suena. Bueno, a mí se me da mucho la pinza, ¿eh? Sergi, envíamelo otra vez. Sergi Martín. No, eso no es cierto, lo de la renta básica universal. Pásamelo. Creo que la semana que viene vamos a hacer, aparte del de Apple, venga, el de la renta básica universal. Venga, que estoy muy pesado con el tema. A mí personalmente me gustó mucho, ganas de ver la segunda parte, sí. Venga, vamos a ver. Sí, hubo un 90-99% de comentarios positivos. Hubo otros, espero estar más mono, entre comillas, y más delgadete en la próxima. La verdad que está un poco... Pero bueno, el tema físico es lo de menos. Pero bueno, son chorradas que digo yo. Vale, vamos a dar un segundo. ¿What? ¿Cómo que no está traducido? Ah, muy bien. Está de puta madre. No tenemos traducción. Entonces, ¿qué hacemos? Si no tenemos traducción, ¿qué hacemos? Houston, tenemos un problema. Ah, vale, está este. Vale, pues está este que es muy parecido. Vale, vamos a...
I'm Bryna Kra, and I'm president of the AMS, and it's my pleasure to welcome all of you to this AMS Josiah Willard Gibbs lecture.
It is much more general. Predict.
Vale, este...
The video frame in a...
Yo quería haber puesto el otro, ¿eh? Vale, vale, pero como no tiene subtítulos, vamos a ver este. Vale. Tendría que haberlo comprobado. Pero bueno, esta es la misma charla, incluso muy reciente, hace nada, ¿de acuerdo? Pero es más cortita y la otra a lo mejor era más profunda, pero es la misma presentación, ¿eh? Utiliza las mismas slides, todo igual.
Good afternoon.
Join Mathematics Meetings. Bueno, todo esto lo hacemos.
Welcome, everybody. I'm Bryna Kra, and I'm president of the AMS, and it's my pleasure to welcome all of you to this AMS Josiah Willard Gibbs lecture. These lectures were established in 1923 to show the public some of the aspects of mathematics and its application. They are named in honor of Gibbs, a mathematical physicist who made deep theoretical contributions in physics, chemistry, and mathematics, something all of us do, right? Yeah. Gibbs is one of the founders of statistical mechanics. He coined the term, and of vector calculus. His influence was so profound that he had even been featured on a US stamp in 2005. The list of previous Gibbs lecturers is a veritable who's who in broad mathematics, including G.H. Hardy, John von Neumann, and Albert Einstein. So today it's my pleasure to add another one to this list and introduce Yann LeCun for the Josiah Gibbs lecture. Yann is the Jacob T. Schwartz Professor of Computer Science, Data Science, Neural Science, and Electrical and Computer Engineering, competing with Gibbs in terms of fields, at the Courant Institute of Mathematical Sciences at New York, and he is the Chief AI Scientist at Meta. He is well known for his work in numerous areas, especially in computer vision and deep learning, and he's one of the developers of things you may be using all the time, the DJVU format that probably somewhere on your computer. He's won numerous awards. I won't list them all because then there would be no time for his lecture, but I will just note that he won the Turing Award recently in 2018. And he's a member of numerous academies, including the National Academy of Sciences, the National Academy of Engineering, and the French Academy of Sciences. Without further ado, let me introduce Yann.
All right, now that Bryna has listed all the prominent speakers of the Gibbs lecture, I'm intimidated. And I don't believe I'll kind of fill the shoes of those names. But let me talk about AI. Obviously, everybody is talking about AI, and particularly about obstacles towards human-level AI. So a lot of people in the AI research and development community are perceiving the idea that perhaps we have a shot within the next decade or so of building machines that have a blueprint that might eventually reach kind of human-level intelligence. The estimates about how long it's going to take vary by huge amounts. The most optimistic people say we're already there.
Bueno, eso ha cambiado, ¿eh? Lo de que la inteligencia humana o AGI, las fechas varían mucho. Podemos decir que todos se han alineado ya a antes de 2030, 2030 o un poquito después. Prácticamente todos, en la industria. Incluido el propio Yann LeCun en algunos posts, Es decir, esto de que no, puede ser que tarde 100 años, 1000. Bueno, yo me acuerdo de algunos medievos, no voy a nombrarlos, algunos participantes de xHUB.AI, alguno ex amigo y con ruptura dolorosa, decían que no lo verían ni nuestros nietos de nuestros nietos de nuestros nietos y cosas como esas, ¿no? Gente de mucho talento. Y por culpa de esas discusiones, sobre todo en un caso concreto, perdí la amistad con alguien que, bueno, la verdad es que tenía un cierto aprecio por él.
Some people who are raising lots of funds are claiming it's going to happen next year, but I don't believe so myself. But I think we have a good shot. And so I'm going to tell you where I think research in AI should go and what are the obstacles. And some of them are really mathematical obstacles. Okay, so why would we need to build AI systems with human-level intelligence? And it's because, you know, in the near future, we're all going to be walking around with AI assistants helping us in our daily lives that we're going to be able to interact with through various smart devices, including smart glasses and things like that, through voice and through various other ways of interacting with them. So we'll have smart glasses with cameras and displays in them, etc. Currently, you can have smart glasses without displays, but soon the displays will exist. Right now they exist, they're just too expensive to be commercialized. This is the Orion demonstration built by our colleagues at Meta. So the future is coming, and the vision is that, you know, all of us will be basically working around with AI assistants all our lives. It's like, you know, all of us will be kind of like a you know, high-level CEO or politician or something running around with a staff of smart virtual people working for us. That's kind of the possible picture. But the problem is we don't know how to build this yet. And really, the current state of machine learning is that it sucks. I mean, in terms of learning abilities compared to humans and animals, it's really very inefficient in terms of the number of samples or trials that machines have to go through before they can reach a particular level of performance. So in the past, the dominant paradigm of machine learning was supervised learning, right? So supervised learning is you give an input to the system, you wait for it to produce the output, then you tell it what output you wanted, and if the output you wanted is different from the one that the system produces, the system adjusts its internal parameters to get the output closer to the one you want, okay? It's just learning an input-output function. Reinforcement learning, you don't tell the system what the correct answer is, you just tell it whether it's good or bad, whether the answer it produced was good or bad. And the main issue with this is that it requires the system to basically produce multiple outputs and ask you, is this good, is this bad, is this better? And that's even less efficient. So it only works for games, basically, or for things that you can simulate really quickly on a computer. So one thing that has...
Bueno, el papel del aprendizaje por refuerzo, casi ridiculizándolo, sería cuestionable. Bueno, el del aprendizaje por supervisado sí, pero el del aprendizaje por refuerzo.
Revolutionized AI in the last few years is called self-supervised learning. And and it works really great. It's really revolutionized AI, but it's still very limited. So self-supervised learning is the basis of large language models and chatbots and things like this, and I'm going to tell you in a minute how it works. But really, animals and humans can learn new tasks extremely quickly, and they can understand how the world works, they can reason and plan, they have common sense, and the behavior is really driven by objective. It's not just kind of predicting the next word in a text. Okay, so how does those chatbots and
Ahí importante el tema, ¿no? De los animales pueden aprender nuevas tareas rápidamente, comprender el mundo cómo funciona, pueden razonar y planificar. Lo del sentido común habría que analizar bien exactamente qué es, y el tema de los objetivos, qué es lo que conduce a esa inteligencia artificial, que podría tener que ver con el tema de la identidad, personalidad o objetivos. ¿Quién define eso? Evidentemente no creo que sea algo autoaprendido. ¿Será establecido o no? ¿Es algo emergente? Bueno.
LLMs work, and I only have 2 slides on it, and then I'm not going to talk about it at all. Okay, so autoregressive large language models. They're trained to predict the next word in a sequence or the next symbol in a sequence of symbols. Okay, they can be words, they can be DNA, music, protein, whatever, discrete symbols. Okay, so you take a sequence of symbols, you feed it to a large neural net, and the architecture of the neural net is such that the system can is trained to basically just reproduce its input on its output. This is called an autoencoder. Okay, so you just take the input and then tell the system, I just want you to reproduce your input on your output. But the architecture of the system is such that to produce one particular variable, the system can only look at the variables that are to the left of it in the sequence. It cannot look at the variable that it needs to predict. Okay? So basically what you're training it to do by doing this, you're training it to predict the next symbol in a sequence. Okay, but you do this in parallel over a large sequence. So you measure some sort of divergence between the input sequence you feed it and the output sequence it produces, and you minimize that divergence measure through gradient, basically gradient-based optimization with respect to all the parameters inside of the predictor function, which is some gigantic neural net which may have tens or hundreds of billions of parameters. Okay, this is really high dimension. Okay, once you've trained that system, when you take a sequence and you run it through it, the system is going to predict the next symbol. Okay, so let's say the window over which it looks at symbols here is 3. In reality, in an LLM, it can be several 100,000, but let's say 3. So you feed 3 words to that system and it produces the next word. Now, of course, it cannot predict exactly the next word, so what it produces is a probability distribution over all the possible words in a dictionary. And typically in an LLM, we don't actually train it to produce word, we train it to produce tokens, which are like subword units, and a typical number of possible tokens would be on the order of 100,000. Okay, so now when you use the system, you feed it a sequence of words called a prompt. You have the system predict the next word, and then you take that and you shift it into the input. So now you can ask the system, what is the second next word? Have it produce it, shift it into the input, produce the third word, shift it into the input. So that's basically autoregressive prediction, a very old concept, obviously, in signal processing and statistics. And it works really well. It works amazingly well. If you make those neural nets really large, you train them with very large input windows on tens of trillions of tokens, data sets that have tens of trillions of tokens, sequences with tens of trillions of tokens. It works amazingly well. Those systems seem to discover a lot of an underlying structure about language or about whatever sequence of symbols you're training it on. But there's a major issue with autoregressive prediction. And mathematicians in the room here would probably do a much better job than me at kind of writing proofs about this, but autoregressive prediction is kind of a divergent process, right? If you imagine that you have those symbols are discrete, so every time you produce a symbol, you have multiple choices, maybe 100,000 choices, and you can think of the sequence of all possible tokens as some gigantic tree with a branching factor of 100,000. Okay, within this gigantic tree, there's a small subtree that corresponds to all answers that could be qualified as correct. Okay, all continuations that you would think are qualified as correct. So if the prompt is a question, you know, the answer would be the produced text would contain the answer. Now that subtree is a tiny subset of the gigantic tree of possible sequence of the symbols. And the problem is, if you assume, which of course is false, that there is some sort of probability of error every time you produce a symbol, and you assume those errors are independent, and that probability is E, then the probability that a sequence of n symbols would be correct is 1 minus e to the power n. Even if e is really small, this has got to diverge exponentially. And it's not fixable within the context of autoregressive prediction. So my prediction is that autoregressive LLMs are doomed. A few years from now, nobody in their right mind will use them. Okay? And that's why, you know, you've heard about LLM elucidation and things like that. You know, sometimes they produce nonsense. And it's essentially because of this autoregressive prediction. So the question is, what should we replace this by? And you know, are there other types of limitation? Now, so I think we're missing something really big in terms of...
Bueno, vamos a ver el chat. Bueno, evidentemente la crítica ha explicado los LLMs autorregresivos y algo que ha repetido constantemente, que es que con estos métodos autorregresivos no vamos al fracaso, vamos al fracaso en el desarrollo de inteligencia humana, ¿no? Esta es sexy Plácido que dice. A ver, te sigo desde entonces. Venga, vamos a ver. Bueno, voy a ir viendo el programa y a la vez los comentarios. No os paséis con el tema de renta básica. A mí mi charla de inversión racional me gustó mucho. Ganas de ver la segunda parte, sí. Hola, Eduardo. César Garrido, ¿qué tal? Urgente renta básica, Plácido, de verdad, gente a favor, neutra y en contra, diversidad de opiniones, te saldría un programa. Sí, lo vamos a hacer la semana que viene, con casos de éxito, ¿no? Intentaré tener, a ver si hacemos como si fuera una xBattle, que son como 6, y hay 2, 2 y 2. Y... De hecho, te sigo desde entonces. Sí, mucha gente a partir de esa charla empezó a seguirme. Los de Alemania. Bueno, pero vuelvo a repetirte, Alberto, que hay que analizar. En el programa lo analizaremos, el caso de Alemania. Y estas no tengo ni idea. A ver, eso de que no tienen ni idea y que mintieron en pleno directo. A ver, cosas concretas. Vamos a ver, ¿qué es la renta básica? No, cualquier cosa en el programa que hagamos de renta básica. No monopolicéis todos los debates, todos los chats con renta básica, porque directamente no voy a ignorarlos. No, el programa piloto de OpenAI y de Google, vamos, de exitoso no tuvo nada. Mira los programas que hicimos de renta básica universal, pero los volveremos a analizar. Analizaremos lo que se está intentando hacer en el mundo y analizaremos qué es lo que se obtiene de ahí. Liberar la mente. Bueno, necesito liberar la mente. Buenas tardes, saludos, Francisco Angulo de la Fuente. Un saludo, Francisco. Dice, esa tarjeta de Welcome parece un producto de cosmética. Ahí vamos, obstáculos. GPT-5 ya hace meses que iba a salir ni el pelo. No, GPT-5 yo creo que ni en 2026 o en 2026 puede ser que enseñen algo. Alberto, tu opinión de Inés es... a ver, ¿me puedes decir tú qué estudios tienes para abordar mínimamente una opinión que puede ser diferente a la tuya en este tipo de temas? Pues eso. Y debatir con gente que piensa diferente a ti sin perder amistad. Qué pena. Ojalá se pueda arreglar. Sé quién es. No. Ya, lo que pasa es que, Eduardo, en ese tema el problema es como... a ver, yo creo que bueno, una salida de pinza total. Vamos, yo hay una cosa que no aguanto, que es la... A ver, yo suelo tener bastante aguante con las amistades. No sé. A ver, no es que tolere ni todo ni nada, ¿no? Soy bastante exigente, ¿no? Pero cuando hay un cariño, o igual que un afecto o lo que sea, ¿no? Y bueno, ahí es que, yo qué sé, se me fue auténticamente la pinza durante tiempo hasta que tuve que decir basta, bloquearlo y a tomar por culo. Pero es que era una persona que habías tenido una amistad. Pero que me ha pasado con más gente, ¿eh? A partir de hacer xHUB.AI hay algunas historias un poco de terror. Y ya cuando una cosa ya duele, ya nada vuelve a ser igual. Ya. Me sabe mal porque no tengo nada en contra a nivel personal, pero se pasó 30.000 pueblos, que yo no hice absolutamente nada. GPT-6 el año que viene y luego... Y el tiempo, en cierta manera, me ha dado la razón, pero que aunque no la hubiera tenido, no es una cuestión de razones, es una cuestión de formas y de respeto. GPT-6 el año que viene, de momento el iPhone dice, sí, va ganando a GPT-4. Sí, eso está buena. ¿No creas una cámara nueva, un poco más de RAM y dos cositas? Bueno, lo del... Yo aquí discrepo con LeCun. Los seres biológicos, dice Eduardo César Garrido. Yo aquí discrepo con Yann LeCun. Los seres biológicos llevan el aprendizaje en parte codificado en el genoma por la evolución, bueno, por el genoma y por la epigenética, ¿no? De hecho, en el cerebro ya hay estructuras al nacer, lo innato. Exacto. Es que hay un somos software. El famoso que dijo, la IA es solo software, por mis cojones. Y es que somos software. Me parece una falacia brutal lo que está diciendo, pero bueno. No, a ver, vamos a ver. Lo he puesto porque, bueno, a Yann LeCun es brillante. Lo que propone sí que yo creo que es una gran mejora y una visión totalmente distinta, pero yo estoy contigo que dice cosas que él mismo se contradice mucho y hay cosas que no estoy de acuerdo con él. No estoy de acuerdo con él. Pero su propuesta, sus modelos, lo que está mostrando Meta es en muchos casos brillante y hay que ver lo que está haciendo. Innovar no es una cosa que pasa cada semana. Me tiene poca eficiencia el MLM. Dice en el fondo que tiene poca eficiencia el Machine Learning, estoy de acuerdo, pero no necesitamos esto. ¿Esto que te refieres? ¿Al pataleo de Yann LeCun contra el Machine Learning? No, Daniel Sete. Dice, ahora todos los tecnólogos son biólogos, neurólogos, sociólogos, clarividentes, echan las cartas. La verdad es que vivimos un momento de locura total. Eso es cierto. Yo veo cada cosa. Ya no entro, en algún... Ya no voy a entrar en mucho debate o Vietnam. Bueno, ayer casi tengo uno en la X-Talks. No, la IA no es razón. Con perdón. La IA... Digo, a ver, no nos metamos. Es que la gente, vamos, te puede venir cualquiera aquí a debatirte a un nivel, ¿sabes? Y yo al final lo voy a decir, ese debate en otro foro y no contigo, porque es que... Fran Vilas, el ser humano corriente no entiende la función exponencial y estos son tecnologías exponenciales. Son sistemas complejos. El tiempo para la evolución de la IA comparada con el tiempo que comprende el ser humano no es lineal y conforme pasa ese tiempo se irá comprendiendo mejor. Totalmente. Debe ser ejemplo de las bacterias en una placa de Petri con suficiente alimento. Hay una cosa que es apasionante cuando... es cierto que echo de menos, en vez de hacer muchos vídeos, que no es que lo haga por rapidez o por hacer mucho contenido y ser el que más contenido hace, sino que como son vídeos que voy a ver y que me apetece ver, pues entonces lo veo con vosotros y lo razono y ya está, ¿no? Y debatimos, pero si se pudiera hacer como este tipo de vídeos con imágenes, cuidado, con VO3 se consiguen cosas increíbles, ¿no? Darranovsky hace unas cosas ahí, bueno, se está viendo en VO3 y otros generadores de vídeo, de cómo funciona a nivel molecular, o que tú comentas de las bacterias, o procesos que se ven que son pura mecánica, o procesos de codificación, intercambio de información, ¿no? A nivel biológico, ¿no? Y eso va a niveles inferiores, siendo cada vez más complejo. Quizá podamos creer que no entender por qué los LLMs o los modelos de lenguaje actuales basados en arquitecturas transformes funcionan tan bien y dónde puedan estar sus límites y por qué, ¿no? Lo hemos comentado muchas veces. Eduardo César Garrido. Este gráfico de Tarta asume que la sintaxis codifica si algo es correcto o no, lo codifica la semántica. Se pueden decir varias cosas de distinta forma. Dice ya lo tenemos por aquí, sí, justo. Que ya venimos con esa predisposición. Sí, vale, vamos a seguir con Yann LeCun.
Like a new concept of how to build AI systems. We're never going to get to human-level AI by just training large language models on bigger data sets. It's just not going to happen. And I'll give you another reason why in a minute. But never mind humans, never mind, trying to reproduce mathematicians or scientists. We can't even reproduce what a cat can do. A cat has an amazing understanding of the physical world. And when I say cat, it could be a rat. And we have no idea how to get an AI system to work as well as a cat in terms of understanding the physical world. House cats can plan really complex actions. They have causal models of the world. They know what the consequences of their actions will be. And humans are amazing. A 10-year-old can clear up the dinner table and fill up the dishwasher without actually learning the task. You ask the 10-year-old to do it, and the 10-year-old will do it the first time. It's called zero-shot learning. Because the 10-year-old has a good mental model of the world and sort of knows, how objects behave when you manipulate them and how they're supposed to behave. A 17-year-old can learn to drive a car in 20 hours of practice. And autonomous driving companies have hundreds of thousands of training data of people driving cars around. We still don't have self-driving cars, at least not level 5 self-driving cars, unless we cheat like Waymo, which is fine. So we have AI systems that can pass the bar exam, they can do math problems, they can prove theorems. But where is my level 5 self-driving car? Where is my domestic robot? We still can't build systems that...
Bueno, los últimos vídeos de conducción autónoma de Tesla auténticamente impresionantes, ¿no? Es que todo esto es a medias, verdad a medias, algunas de las críticas, que no digo que muchísimas cosas que dice sean ciertas, ¿no? Pero cuidado con todo lo que dice.
That deal with the real world. The physical world, turns out, is much more complicated than language. And that's called the Moravec paradox, right? There is this...
De ahí la propuesta de Sutton, ¿no? Con el paper La era de la experiencia, donde los datos no vendrán del lenguaje, sino de la interacción. También lo de Arcagi 3, acordaos el Reason Interactive, que es interacción en un escenario de juegos, ¿no? Donde el lenguaje ya no es la base, ¿no? Todos van en esa misma dirección.
Idea that tasks that are complicated for humans, like computing an integral, solving a differential equation, playing chess or Go, planning a path through a bunch of cities. Those are kind of hard tasks for humans. It turns out computers are much better than us at this. They're so much better than us at playing chess and Go that really humanity sucks. And what that tells you is that when people refer to human intelligence as general intelligence, that's complete nonsense. We do not have general intelligence at all. We're extremely specialized. Okay, so we're not going to get to human-level AI by just training on text. And there is an interesting calculation you can make. So a typical LLM, a modern one, is trained on something like 2 10 to the 13 tokens, 20 trillion. And each token is about 3 bytes, so that would be 6 10 to the 13 bytes. Let's round this up to 10 to the 14 bytes, okay? That would take a few 100,000 years for any of us to read through this. That basically constitutes the entirety of all the text available on the internet publicly. That seems like an incredible amount of training data, but now take a human child, a 4-year-old has been awake a total of 16,000 hours, which, by the way, corresponds to 30 minutes of YouTube uploads. Not that much data. We have 2 million optic nerve fibers, 1 million per eye going to the visual cortex. Each optic nerve fibers carries about 1 byte per second, roughly. Maybe a little less, but who cares? So do the calculation, and that's about 10 to the 14 bytes in 4 years. There's just enormously more information in the physical world, in sensory information that we get from vision and touch and audition, than there is in all the text ever produced by all humans. So again, we're never going to get to human level AI unless we can get systems to learn how the world works by observing the world. There's just way more information there than there is in text.
Eso es cierto.
And psychologists have studied this. You know, babies kind of learning various things about the real world, mostly by observation in the first few months, because babies really can't act in the world, you know, beyond their own limbs in the first 3 or 4 months. And so they learn a huge amount of background knowledge about the world, mostly just by observation. And it's a form of self-supervised learning that I think we absolutely have to reproduce if we want AI systems to reach animal level or human level intelligence. So babies learn notions like object permanence, the fact that if an object is hidden behind another one, it still exists. Stability, you know, natural object categories without knowing the name of it, of them. And then things like intuitive physics, gravity, inertia, conservation of momentum, you know, this kind of stuff. Babies learn this around the age of 9 months. So if you show a scenario to a 6-month-old of an object that appears to float in the air, like the little scenario at the bottom left, 6-month-old babies won't be particularly surprised. But a 10-month-old baby will look at it with big eyes like the little girl here and be really surprised because by then they've learned that objects that are not supported are supposed to fall. Okay? And that just happened by observation, a little bit by interaction at that age. Okay, so to get to human level AI, we're going to need, and we don't call this AGI at Meta, because again, human intelligence is not general. So we call this AMI, Advanced.
Bueno, un término que utiliza en todos los textos Meta, que es en vez de AGI, pues AMI, ¿no? AMI, Advanced Machine Intelligence. Bueno, si teníamos pocos términos, pues uno más. Y eso de que la inteligencia no sea general, la generalización es una cualidad de la inteligencia humana.
Advanced Machine Intelligence, we pronounce it AMI, which means friend in French. And so we need systems that learn world models, mental models of the world from observation, from sensory input, so they can learn intuitive physics and common sense and things like that. Systems that have persistent memory, systems that can plan complex action sequences, systems that can reason, and systems that are controllable and safe by design, not by fine-tuning like current AI systems. And the only way I can think of building a system like this is to completely change the type of inference that is performed by those systems.
Esto de que los sistemas sean controlables es fundamental. Esto sí que sería una base, lo que está diciendo sí que es cierto, ¿no? No a través de fine-tuning, no a través de un agente o una IA que controle otra IA, no, sino de base, en diseño, ya es así.
So the current type of inference that LLMs do or neural nets of various types is that you put an input, you run through a fixed number of layers in the neural net, and you produce an output, okay? An LLM does this. For every token, there's a fixed amount of computation spent to produce each token. So the trick to get an LLM to spend more time thinking about something is to trick it into producing more tokens. That's called chain of thoughts. And this is heralded as a huge progress in AI over the last few years. So it's very limiting. The type of functions you can compute by running signals through a fixed number of layers in a neural net. Let's say a neural net of a reasonable size is limited, right? Because most tasks that you want to solve require many steps of computation. You cannot reduce them to just a few steps. You know, many computational tasks are intrinsically serial. sequential, not parallel. So you may have to spend more time thinking about more complex functions than answering simple questions. So the better way of performing inference would be inference by optimization. So basically, you have an observation, you run it maybe through a few layers of a neural net, and then you have a cost function, which itself is a neural net that produces a scalar output, and what it's going to measure is the degree of compatibility or incompatibility between the input and a hypothesized output. Okay, so now the inference problem becomes one of optimization, searching for an output that minimizes its objective function. I call this objective-driven AI, but really it's not a new concept at all. Like most probabilistic inference systems perform inference using optimization. I know there's quite a few people in the room who have worked on optimal control, so planning and optimal control. Motion model predictive control, for example, produces output through optimization. I'll come back to that. Okay, so this idea is really not new, but we've forgotten about it. And I think we have to go back to it. We have to build systems whose architecture is such that they can perform inference by optimization. The output is not an output, it's a latent variable that you optimize with respect to. And this is really classical in...
Que esto suena a un paper, me suena esto a un paper que ha sacado Microsoft sobre cómo el siguiente token, cómo se calcula con aprendizaje con refuerzo. Y en definitiva es esa optimización, ¿no? No simplemente...
traditional AI, if you want. The idea that you search for a solution among a space of possible solutions. That's very traditional. It's just kind of forgotten. The type of tasks that can be solved this way would be somewhat equivalent to what psychologists call system 2. So in human behavior, there's two types of producing an action. One is called system 1. This is the kind of task that you do kind of subconsciously. You can take the action without even thinking about it. And then system 2 is when you have to devote your entire conscious mind, if you want, to the task and then plan, think about it for a while and then plan a sequence of actions. Like if you are building something, for example, and you're not used to that task, you will use system 2. When you're proving a theorem, you're certainly using system 2.
Bueno, aquí ha hecho una afirmación bastante importante, ¿no? Si con los modelos de lenguaje, modelos multimodales, teníamos el sistema 1, el sistema intuitivo, referenciado en este sentido y bajo este concepto por Ilya Sutskever y Geoffrey Hinton, ¿no? Sistema 1, él dice que la optimización, la inferencia basada en la optimización sería ese modelo 2. Pero claro, entonces mantendría el sistema 1, sistema 2, estaría creando el sistema 2 en esa arquitectura. Bueno, ahora lo veremos.
So, what is the best way to sort of formally represent what this process of inference by optimization is? And it corresponds to basically this idea of energy-based models. So,
bueno, los modelos basados en energía nos llevarían a Carl Friston, ¿no? Las mantas de Markov y su principio de energía libre, inferencia activa, etc., etc., etc.
An energy-based model is a model that computes a scalar number that measures the degree of incompatibility between an input x and a candidate output y, and performs inference by minimizing this energy with respect to y. Okay? I'm going to call this energy function f. Why f, not E, like energy? Because it's F like free energy. Okay, we're getting closer to the Gibbs kind of thing here. So that's the inference process. Now, modeling a dependency between two variables through a scalar energy function of this type is much more general than just learning a function from x to y. And the reason is that there might be multiple y's that are compatible with x. For example, if the problem you're trying to solve here is translating from English to French, there's many ways to translate a particular English sentence into French that are all pretty good. So they should all have low energy, okay, to indicate that those two things are compatible for the translation task. But there's no like single output that is correct. So basically, I'm talking about implicit functions here, right? Represent a dependency between variables through an implicit function, not an explicit one. I mean, a very simple concept, surprisingly difficult to grasp for a certain type of computer scientist. Okay, so how can we use those energy-based models in the context of an intelligent system that might be able to plan actions? Okay, and this is kind of a diagram, a block diagram perhaps, of the internal structure of this energy function, scalar energy function. So in this diagram, round shapes represent variables, either observed or latent. Modules that are like flat on one end and rounded at the other end represent deterministic functions, let's say a neural net that produces a single output. Rectangles represent objective functions. Basically, scalar output, the output is implicit here, but scalar valued functions that takes a low value when the input is acceptable and larger values when it's not. So here you can have two type of objectives. One that measures to what extent the system accomplishes a task that you want it to accomplish, and another set of objectives that may be guardrails. So things that prevent the system from doing stupid things or dangerous things or self-destructive or dangerous for humans around. Okay, so observe the state of the world, run it through a perception module that produces a representation of the current state of the world. Now, of course, you don't have a complete perception of the state of the world, so you might want to combine this with the content of a memory that contains your idea of the rest of the state of the world that you might have in your memory. Combine those two things and feed them to a world model, and what the world model is supposed to do is predict the outcome of taking a particular sequence of actions. Okay, so the action sequence is in the yellow variable box, and the world model predicts a representation of the world that will result from taking this sequence of actions. Now feed this predicted representation to your objectives, and then since all those modules are differentiables, they're all neural nets, you can backpropagate gradients through the action sequence, and by gradient descent, or something of that type, gradient-based optimization, find an action sequence that minimizes the objectives. And that's just planning. Okay? So that's a process by which a system would be able to perform inference through optimization, but it needs to have this kind of mental model of the world to be able to predict what the consequences of its actions are going to be. Now, this is a very classical view in optimal control, the idea that you have some sort of model of the world or the system you want to control, and you feed it a sequence of actions, and you can sort of predict, you have, I don't know, a rocket you want to shoot to the space station, and what you have is a dynamical model of the rocket, and you can hypothesize a sequence of controls, and then predict where the rocket is going to end up, and you can have a cost function that measures to what extent the rocket is near or far from the space station, and then by optimization, figure out a sequence of controls that will get the rocket to the space station. Okay? Very classical. It's called model predictive control. It's used everywhere in optimal control robotics, and has been used by rocket trajectory planning since the 60s. Now, of course, the world is not entirely deterministic, so your world model may require latent variables, which are variables that you don't know the value of. Nobody is telling you what values they take, and they could take a number of different values. Maybe they're drawn from a distribution, and they might produce multiple predictions. So planning under uncertainty with a world model that has latent variables that basically represent everything you don't know about the world, or that would allow you to predict, would be a good thing, but that's not a solved problem. And what we actually want to do is hierarchical planning. So all of us do this, animals can do this. No AI system today can learn how to do hierarchical planning. We can get them to do hierarchical planning by building everything by hand, but no system really knows how to do hierarchical planning. So let's say I'm sitting in my office at NYU, and I decide to go to Paris. I'm not going to be able to plan my entire trip from my office at NYU to Paris in terms of millisecond by millisecond muscle control, which is kind of the lowest level actions I can take, okay? I can't do it because, first of all, it's too long of a sequence. Second of all, I don't even have the information, right? I don't have full knowledge of, whether the traffic light is going to be red or green, so do I need to, plan to stop or cross the street? But at a high level, I can have a high-level prediction of my mental model that says, if I want to go to Paris, I need to go to the airport and catch a plane. Okay, now I have a sub-goal, going to the airport. How do I go to the airport? I'm in New York, so I can go down in the street and hail a taxi. How do I go down in the street? Well, I'm sitting at my desk, so I need to stand up and go to the elevator, push the button, and then walk out the building. How do I go to the elevator? I need to stand up from my chair, pick up my bag, open the door, walk to the elevator, avoiding all the obstacles on the way. Okay, and at some level, when you go down the hierarchy, you're going to get to a level where you're going to be able to plan your millisecond by millisecond muscle control because you have all the information in front of you, right? So standing up and opening the door, I can plan ahead of time. So this problem of learning world models, learning hierarchical world models, learning abstract representations of the world that allow us to make those predictions at long range or short range so that we can do planning. Nobody has any idea of how precisely how to do this, how to make this work. So if we assemble all of those pieces that I told you about, we end up with something called cognitive architecture for AMI, consisting of a world model, various objective functions, an actor that is the system that optimizes the action to minimize the cost, a short-term memory, in the brain it's the hippocampus, a perception module, that's the entire back of the brain, a configurator, let's forget about this. I wrote a long paper about this 2.5 years ago, which I put on Open Review, it's not on archive, where I explain where I think AI research should go if we want to kind of make progress in that direction. This was before the recent excitement about LLM, although LLMs were already around, but I never believed they were the answer to human level AI. Okay, so how do we get systems to learn mental models of the world from sensory input like video? Can we use this idea of autoregressive prediction, similar to what I explained before that LLMs were using, to train a generative architecture to predict what's going to happen in a video, predict the next few frames in a video, for example? And the answer is no, it doesn't work. I've tried to work on this for 20 years, complete failure. It doesn't work. It works for discrete symbols, for predicting discrete symbols, because handling uncertainty in the prediction is simple. You produce a vector of probabilities, a bunch of numbers between 0 and 1 that sum to 1, and that's how you handle uncertainty. The problem now is, how do you predict a video frame in a high-dimensional continuous space where we don't know how to represent probability density functions in any kind of meaningful way in things like that? We can represent them as an energy function that we then normalize. Physicists have been doing this, okay? But it's intractable. Most of the time, for most forms of energy functions, if you take e to the minus the energy function and normalize it, the normalization constant is intractable. So this idea of using generative models for training a system to predict videos doesn't work. A lot of people are working on it at the moment, but what they are interested in is not learning world models, it's actually generating videos. If you want to generate videos, of course you should do this. Generating cute videos. But if you want your system to really understand the underlying physics of the world, that's a losing proposition. And the reason is, if you train a system to make a single prediction, okay, which is what generative models do, what you get are blurry predictions, essentially. Because the system can only predict the average of all the possible futures that may happen. So my solution to this is something called JEPA, that stands for Joint Embedding Predictive Architecture. And that's what it looks like. Okay, you may not immediately spot the difference with the generative architecture, so let me make that more obvious. On the left, generative architectures. The function that you're minimizing during training is basically a prediction error. right? So predict Y, observe X, observe Y during training, and just train a system to predict Y. Okay, this is like supervised learning, except Y is part of X if it's a sequence. Okay, so self-supervised. This works for discrete Y, doesn't work for continuous high-dimensional Y. On the right, you have the joint embedding predictive architecture. So now both X and Y are run through encoders. And what the encoders do is that they compute an abstract representation of both X and Y. Okay, the encoders might be different. And then you make the prediction, you perform the prediction in that representation space. Now this is a much easier problem to solve in many ways because there are many details in the world that are completely unpredictable. And what a JEPA architecture will do is basically find an abstract representation of the world so that all the stuff that cannot be predicted is eliminated from that representation. Think of the encoder function as some sort of function with invariance so that the variability of the input Y that correspond to things you just cannot predict are eliminated in the representation space, right? So for example, if my video is a video of this room and I point the camera at the left side, I turn slowly and I stop the camera here and I ask the system to predict what's going to happen next in the video. It can certainly predict that there's going to be people sitting in seats, etc. It cannot possibly predict where everybody is sitting, what everybody looks like, what the texture of the ground is, or on the walls, okay? There are many things that you just cannot predict, you just don't have the information. And so instead of spending a huge amount of resources attempting to predict things that you don't have enough information for, just eliminate it from the prediction process by learning representations where those details are eliminated. So there are technical difficulties with this. Okay, so the conclusion to this is, if what I'm claiming is right, we're much better off using the JEPA architectures than generative architectures, we should abandon generative architectures altogether. Everybody is talking about Gen AI. And I'm telling people, abandon generative AI. That makes me super popular, I can tell you. Particularly among my colleagues who spend a huge amount of effort actually building Gen AI systems. In fact, their whole organization is called Gen AI. Okay, so I mean, there's different flavors of those things with latent variables, etc. But I'm not going to go into those details. But there is an issue, which is how you train those things. Okay, so basically, training a system like this to learn dependencies consists in learning an energy function in such a way that the energy function takes low values on your training samples, okay? So at a point, xy, where you have data, the energy should be low, but then the energy should be higher everywhere else. So imagine xy kind of lie on some manifold. You want the energy function to be, let's say, 0 on the manifold, and then to kind of gradually increase as you move away from the manifold. And the problem with this is that I only know of 2 ways of training systems like this. If this energy function is parameterized in such a way that it allows it to take a lot of different shapes, you can have an issue, which is that it can collapse. If you just make sure that the energy is low around the training samples and you don't do anything else, you might end up with an energy function that's completely flat. That's called a collapse. So there are 2 methods to prevent collapse. One is you generate contrastive samples, those blinking green points, and you push their energy up. Okay, so you figure out some loss function which, given a set of training samples and a set of contrastive samples are outside the data manifold, is going to push down the energy of the observed samples and push up the energy of the contrastive samples. Okay, those are called contrastive methods. And the problem with them is that they don't work very well in high dimension because the number of contrastive samples you need to generate grows exponentially with the dimension of the space. So there's an alternative that you could call regularized methods. And what those methods are based on is essentially coming up with some regularizer function that, if you minimize it, will minimize the volume of space that can take low energy, that has low energy. That sounds a bit mysterious of how you do this, but in fact there is a lot of things that have done this in the context of applied mathematics, for example, in sparse coding. This is exactly what sparse coding does. When you sparsify a latent variable, you basically minimize the volume of space that can take low energy, reconstruction energy. Okay, so those two methods, contrastive methods and regularized methods. And there's different types of architectures that can collapse or not. Okay, this is the Gibbs lecture, so I have to mention Gibbs. This is how you turn an energy function into a probability distribution. You use the Gibbs-Boltzmann distribution. Okay, so take exponential minus the energy multiplied by some constant, which is akin to an inverse temperature, and then normalize by the integral of this over the entire domain. And what you get is a properly normalized probability distribution, conditional probability distribution of y given x. And if you really are insisting on doing probabilistic modeling, the way you should train your energy-based model is by basically minimizing the negative log of that conditional probability over your training set. The problem is that that's intractable because the partition function, the normalizing term, is generally completely intractable. So you would have to use approximations like, variational approximations or Monte Carlo approximation. And I tell you, a good chunk of the machine learning community has been spending a lot of effort trying to do this, getting inspiration from physics and from statistics and various other things. I've made a chart. I don't expect you to read any of it here, but this is sort of various classical methods as to whether they are regularized or contrastive. Those methods, whether contrastive or regularized, have been extremely successful to basically pre-train a vision system to learn representations of images in a self-supervised manner. And the idea for this goes back to the early 90s, a paper of mine from 1993 and a couple more in the mid-2000s with some of my students at the time. There's more recent papers from Google, and a lot of people have been working on contrastive method. You may have heard of a model called CLIP, which is produced by OpenAI for learning visual features using text supervision. It's also a contrastive method. But again, it doesn't scale very well with the dimension. So I prefer regularized methods. And the question is, how do you make this work? One way to make this work is you have to prevent the system from collapsing, and a way to prevent the system from, so what does a collapse produce here? A collapse will consist in minimizing the prediction error, okay, D of sy tilde, and only doing that. And what the system can happily do is completely ignore x and y, produce constant sx and xy, and then your prediction problem is trivial. Your prediction error is 0 all the time, okay? But you have a collapsed model that doesn't do anything for you. So one way to prevent this from happening, and that's basically a regularization term, is attempting to maximize the information content coming out of the encoder, or the two encoders, okay? So have some estimate of information content, I of Sx and I of Sy, put a minus sign in front and minimize that. Now, that's a challenge because we don't know how to maximize information content. We know how to minimize it because we have upper bounds on information. We don't have lower bounds on information. And so what we're going to do is come up with some approximation, making some assumptions about information content, knowing that it's actually an upper bound on information content, and we're going to push it up and cross our fingers so that the actual information content actually follows. Okay? And it works. It's not well justified, but it's better justified than anything else that people have done. So it would be nice if you could come up with lower bounds on information content, but frankly, I don't think it's possible. Because there may be complicated dependencies that you don't know the nature of, and so it doesn't work. So the basic idea of how do you kind of put a number in a sort of differentiable objective function on information content, and the basic idea is make the representations coming out of your encoder fill the space. Okay, and that idea has been proposed by multiple people almost simultaneously in different contexts. And there are basically two ways to do this. So the contrastive methods should be called really sample contrastive, right? So take a matrix of vectors coming out of your encoder for a number of samples. Contrastive methods attempt to make the vectors coming out of the encoder all different. Okay? So imagine they're all on the surface of a sphere because you normalize them. You're basically pushing all those vectors away from each other so they fill up the space. It doesn't work too well. I mean, you need basically a lot of rows for this to work, to do something useful. If you have a small number of rows, then it's very easy to have random vectors, pointing orthogonal directions. So you need a lot of rows for this to work. So the converse is dimension contrastive methods, where you take the columns of that matrix and you try to make the columns different from each other, maybe orthogonal to each other. And that only works if you have a small number of rows relative to the dimension, because otherwise it's too easy. You have a small number of high-dimensional vectors that need to be orthogonal. I mean, take them randomly, they'll almost be orthogonal. Okay, so you have kind of a duality between those two things. In fact, we have a paper on the fact that those two things are dual of each other. But I prefer the second one because they can deal with high-dimensional representation space, whereas the first one really can't. So what we've come up with is something we call VICREG, that means variance, invariance, covariance, regularization. And basically the idea there is you take the SX representation and you have a cost function that insists that over a batch of samples, the variance of each variable is at least 1 using a hinge loss. And then a second cost that insists that the off-diagonal terms of the covariance matrix, so basically this matrix transpose multiplied by itself, that the off-diagonal term of the covariance matrix are as close to 0 as possible. So basically you're trying to decorrelate the individual variables, make the columns of that representation matrix orthogonal. And other people have had kind of similar ideas, Yima at Berkeley and some of my colleagues at NYU with a method called MMCR. And we have some theorems that prove that in certain conditions, when you apply this criterion to decorrelate, after going through some nonlinear function, what you're actually doing is making the variables pairwise independent, not just uncorrelated, which is interesting. But still, this is all kind of a little wishy-washy. So a lot of challenges, I think, for astute mathematicians. Now, I'm going to skip this about latent variables because I don't have time. I'm just going to show you the last slide about this because, again, that has to do with Gibbs. The fact that if you want to minimize the information content of a variable, which you need to do if you have a latent variable, a good way to do this is to make it noisy. So instead of inferring a single value for this variable, you infer a distribution over this variable, and you maximize the entropy of that distribution. And the best way to do this is by writing down what's called a variational free energy and minimizing that. And Gibbs had something to say about that. This I'm also going to skip for lack of time. You can actually use this VICREG technique and apply it to PDE. PDE, not solving, but like, for example, finding the coefficients of a particular PDE by just looking at windows on the solution. So basically, take the space-time solution of a PDE, take two windows and train a system to produce a representation of those two windows using this VICREG criterion by basically forcing the two representations to be identical regardless of the pair of windows. And the only thing that the system can extract, which is common between different windows in the solution of a PDE, are basically the coefficients of the PDE, a representation of the equation of the differential equation itself. And when I don't have time to explain, but when you apply this to various situations, it actually works. If you want more details about this, you might want to talk to Rondal Balestriero, who is sitting somewhere here. Where are you, Rondal? Right here, okay. He's one of the main authors of that paper. And he can give you some details. The bottom line is that when you use this VICREG stuff to learn the coefficients of a PDE, you actually get a better prediction than if you train it in supervised mode, which is kind of interesting. Okay, there's another set of methods, alternative to VICREG, called distillation-based methods. And we use them because they work well, but I don't like them because they're even less theoretically justified than than the VCREG information maximization techniques. And I'm not going to go into the details of how they work, but you're minimizing a function that is not actually being minimized by gradient descent. It's a mess. There are some theoretical papers on this. I listed one at the bottom here, but only in the case of kind of linear encoders and predictors. And really, it's not such a satisfying method, but it works really well. And a lot of people have been using it for learning features of images in a self-supervised manner. There's a technique called IJPA, which I won't have time to describe in detail, but it does a really good job at kind of learning representations of images that you can use then for a subsequent task that would be supervised, but without requiring too many labeled samples. And then there is a video version of this called Video JEPA. So you take a video, you mask a big chunk of it at all times, for example, and then you train some gigantic neural net, a JEPA architecture to predict the internal representation of the full video from the representation of the partially masked one. And what you get in the end is a system that does a really good job at representing videos. You can use that representation as input to a system that can classify the action taking place in the video and do things of that type. And I'm not going to bore you with tables of results, but it works really well. And one really interesting thing about this technique, this is a paper that we just finished and we're submitting. When you test those systems and you measure the prediction error they're doing on a video, if you show them a video that is physically impossible, like an object disappears or changes shape spontaneously, it tells you that can't happen. My prediction error goes through the roof. And so this system has kind of learned a very basic form of common sense, a little bit like, the babies I was talking about earlier. And that's really a surprising result because the system is really not trained to predict, it's just to kind of fill in missing parts. And we've been using kind of self-supervised encoders and predictors to do planning. So I'm coming to this idea of world model. So let's say you have a picture of a state of the world and the system can control a robot arm. And you want the system to basically act in such a way that the final state of the world looks like a particular target. So let's say you have a bunch of blue chips on the table and you want to kind of move a robot arm so that at the end the blue chips are all within a nice little square as represented here in the middle. And so train an encoder, so we use DynoV2, which is a pre-trained encoder, and then train a world model to predict what is going to happen at the representation level when you take a particular action. Can you predict the resulting effect on that board with blue chips? And then once you have that world model, which you can train from random data with random actions and random blue chips, can you use it to plan a sequence of actions so as to arrive at a particular result? And I'm going to cut to the chase. So, there's various problems that we have applied this to, and it works pretty well for planning several things. But here is the result for the blue chips. Okay, so what you see here is a video. You don't see the actions of the robot arm, but it's actually taking actions. And what you see at the top is what's happening in the world. And what you see at the bottom is what the system predicts is going to happen in its own internal world model. We trained a separate decoder to kind of produce an image of what the internal thinking of the system is. Let me play this again. So at the bottom here, you see kind of the configuration kind of progressing as the robot kind of pushes things around. And then the end state is not exactly a square, but it's pretty close. And this is a very complex dynamical system where the chips are interacting with each other. You could not, really kind of model this sufficiently accurately to kind of do planning with a hand-constructed model, really. With kind of similar work for planning and navigation in real world. I'm going to skip this because I'm running out of time. So my recommendations, abandon generative models in favor of the joint embedding architectures, abandon probabilistic models in favor of energy-based models, abandon contrastive methods in favor of regularized methods, abandon reinforcement learning, I've been saying this for a decade now, in favor of model predictive control and planning. And if you are interested in human-level AI, just don't work on LLMs. In fact, if you are a PhD student in AI, you should absolutely not work on LLM because you're putting yourself in competition with enormous teams with tens of thousands of GPUs at their disposals. You're not going to be able to contribute anything. Okay, problems to solve. Large-scale world models. How do you train them on multimodal inputs? Planning algorithms. I think there's a lot of expertise perhaps in the room here in optimal control in sort of various ways to perform optimization. When you use gradient-based method for planning, you get hit by all kinds of local minima issues and non-differentiability and all that kind of stuff. So maybe methods like ADMM would help. JPA with latent variables and planning with non-deterministic environment, regularizing latent variables, hierarchical planning, etc. And so, you know, what are the mathematical foundations of energy-based learning? When we're stepping out of probabilistic learning, we're getting into the unknown, and characterizing what is appropriate to do there is not clear. Learning cost modules, I didn't talk about this, but that's also an issue. Planning with inaccurate world model and how you adjust the world models. Okay, so maybe if we solve all those problems within the next decade or half decade, we're going to be on a good path towards building systems that are truly intelligent, that are capable of planning and reasoning. And I think the only way for this to work is if the platforms are open source. I've been a big advocate of open source AI, and I really believe in this. But if we succeed, maybe AI will be sort of a big amplifier of human intelligence, so that can be only good. Thank you very much.
Bueno, una auténtica pasada la charla de Yann LeCun. Una auténtica pasada. Vamos a ver otra de 10 minutos donde va a ser más accesible porque es impresionante. Bueno, a mí me han dado ganas de parar la charla y me han abierto los papers de VJPA2. Y what the fuck. Bueno, vamos a ver qué habéis dicho en el chat. El niño Becerra no traigo, Daniel Reventos. Venga, me voy a apuntarme alguno, pero el niño Becerra, vamos, va a ser que no. Daniel Reventos. Pero a ver, es que, Alberto, si alguien opina distinto a ti, ¿ya no sabe? Claro, es que... y aquí hay una parte de elección y no de opinión. Y no tiene nada que ver con el conocimiento. De algunas cosas sí entiendo que cuanto más sepas, mejor puedes decidir, pero hay un tema de elección que no tiene nada que ver con el conocimiento. Tiene que ver con el modelo del mundo o con el tipo de sociedad que quieres crear. Daniel Raventos, venga, lo apuntaré. Pero vamos, esta gente no creo que se acceda a participar, ya te lo digo yo. Lamba dice, no sé quién se ha creído este señor que es para contradecir a Pedro Sánchez. Es que es verdad. ¿Quién se le ocurre contradecir a Dios? De verdad es que España tiene un gran problema y que se llama Pedro Sánchez, se llama clase política, se llama sistema, se llama idiosincrasia, se llama sociedad de aborregada. Tenemos un grave problema para construir un gran país si es lo que queremos hacer. No, vamos a ver, aquí es una arquitectura cognitiva inicial. Claro que faltan piezas. Por supuesto. No estoy de acuerdo. Que las demás zonas del cerebro ya las hayamos desarrollado con los LLMs. ¿Qué zona del cerebro crees que hemos desarrollado con el LLM? Que con este tipo de arquitecturas no. Es simplemente él está analizando matemáticamente y proponiendo cosas que son mejores y algunas limitaciones. Los LLMs, claro que pueden conseguirse cosas, incluso a lo mejor cosas que él ha mostrado, pero yo entiendo que aquí también hay una parte de eficiencia o de sentido común, ¿no? Sí, es una charla muy extensa de muchas cosas y, a ver, no podemos dar opiniones de una cosa tan compleja porque entonces ya estamos como zumbaos y medio. Sí, este directo es ahí, a ver, es para coger el paper que tiene de Towards Human Intelligence, los nuevos papers que han salido de VJPA 2, que os he puesto al principio. Es una dirección totalmente distinta. Y yo creo que me parece que vamos a vivir una transición de piezas. A ver, al final vamos a hacer como un Lego, arquitecturas cognitivas con algunas nuevas piezas y entiendo que sustituirán unas por otras y habrán arquitecturas distintas en el mercado, no lo sé. Yo creo que habrán sistemas híbridos en ese sentido. Yo no creo que las compañías vayan a empezar de cero, tumbar todo lo de los LLMs, lo autorregresivo, el sistema 1 ya diseñado, todos los entrenos que se han realizado. No, yo creo que se aprovecharán e irán haciéndose piezas nuevas, casi como un Frankenstein. Arquitecturas cognitivas. Sí, JEPA es una arquitectura cognitiva. Una AMI. AMI, ¿no? Decía, no sé cómo la pronunciar. Bueno, pero es que eso no es... A ver, esto que... Él lo dice que es el sistema 2. Pero bueno, es una arquitectura cognitiva. Dice, no es que tenga razón Yann LeCun. Es que lo que dice... no hay mucho que debatir. Es una explicación... podemos, bueno, entrar en debate científico, pero no es un tema de opinión. Claro que tiene razón. Ahora, no se puede llegar o avanzar exclusivamente con los LLMs, no. Pero es que todo el mundo coincide. Ahora, ¿qué? ¿Vamos a una arquitectura totalmente nueva? ¿Va a haber una transición? ¿Puede también la IA automejorarse en ese proceso de tal manera que lo que se genere no esté bajo nuestro control? Porque este tipo de arquitecturas es una arquitectura creada con una mente humana, no con un proceso que nosotros no controlamos. Si tuviese razón LeCun, bueno, quedaría muy diluido esa lección amarga de Sutton, o no, sería a otro nivel. Pero yo creo que hay un punto en que nosotros ya ahí ya no entramos ni a crear ni diseñar, sino que es una emergencia de la propia arquitectura. Pero lo que hacemos es alquimia. Y el propio Yann LeCun lo hace igual. Lo que pasa es que aplican métodos matemáticos más eficientes o menos. Me ha gustado mucho lo del utilizar métodos de energía, ¿no? Es decir, unir bueno, pero eso lo ha hecho Carl Friston, ya tuvimos esa charla. La inferencia activa, principio de energía libre, y que en definitiva es unir el mundo de la información y de la energía, la entropía, todo este mundo que nos lleva a sistemas, arquitecturas de aprendizaje, el modelo del mundo. Bueno, ahí coinciden todos, ¿no? El modelo del mundo es una pieza básica y tecnologías como de mejora continua, Alpha Evolve, las máquinas de Gödel, pero cosas más avanzadas. Hoy ha salido una noticia que luego miraré, que no sé si es cierta, que dice que OpenAI tiene su propia máquina autoevolutiva o de self-improving llamada Alice. No sé si es cierta la noticia o es fake, ¿no? Así que tomar esto con pinzas. Coger esto con pinzas. No sabemos. Entonces, podemos opinar todos, quien quiera opinar, por supuesto, pero no sabemos. Vale, pues vamos a ver el otro trocito de... A ver, realmente lo que sí que es cierto cuando se observa este nivel tan alto, ¿no? Evidentemente, de desarrollo de la IA o futuro desarrollo de la IA, con toda esta base matemática que es la base de la inteligencia artificial, yo creo que a todo el mundo tiene que causarle un respeto y deberíamos ser más contenidos en opiniones y formarnos más y escuchar más y aprender más antes que emitir dogmas que no dejan de ser una traca de la locura interna de cada uno. tenemos que tener un gran respeto por esta disciplina y por este gran reto, por lo que se está consiguiendo y se ha conseguido, ¿no? Vamos a poner el otro fragmento, dura 10 minutos. Este sí que es en plan podcast y opinión, entonces va a ser como más divertido. Pero pues hemos hecho los dos porque yo creía que era, creo y es acertado, es necesario. Esa primera charla podéis ver la de Columbia Engineering, que es más larga aún. Entonces veis dos distintas. A ver. Vamos a ver, es un clip de un podcast, ¿vale? Este sí que tiene traducción. Vale, vamos a ver, esperaos que lo ponga. Ah, yo digo, no tiene. Estoy un poco cansado. Vale. Vale, vamos a ponerla. Y vamos a ver qué dice.
We are not going to get to human level AI by just scaling up LLMs. This is just not going to happen, okay?
That's your perspective.
There's no way, okay? Absolutely.
Dice, esa es tu perspectiva. Dice, no hay manera. Yo, en ese sentido, al nivel que... A ver, yo no digo que el LLM desaparezca y no sea una pieza que se pueda integrar, sobre todo en el tema del lenguaje, ¿de acuerdo? Pero es un sistema 1. El sistema 2 necesario o la arquitectura cognitiva no está en lo que estamos viendo. No hay más.
Absolutely no way.
Pero vamos, eso también está dicho por Demis Hassabis, por el propio Ilya Sutskever, etc. ¿no?
And whatever you can hear from some of my more adventurous colleagues, it's not going to happen within the next 2 years. There's absolutely no way in hell to, pardon my French.
Bueno, en los próximos 2 años no han dicho 2030, estamos en 2025, pues no, en 2027 no vamos a verlo. Ya se dijo que de 2025 a 2028 va a ser la era de los agentes, multiagentes, arquitecturas, bueno, a lo mejor más de juguete cognitivas, pero no llegaremos al nivel de que se está planteando nuevo por parte de Yann LeCun y otros, ¿no? Como Demis Hassabis, Ilya, etc.
The idea that we're going to have, a country of genius in the data center, that's complete BS, right? There's absolutely no way. What we're going to have, maybe.
Bueno, fijaos la frase, ¿no? Esta de, creo que es de Sam Altman, de que vamos a tener genios en data centers. Dice, es una absoluta basura. De ninguna manera lo vamos a conseguir.
Is systems that are trained on sufficiently large amounts of data that any question that any reasonable person may ask will find an answer through the systems. And it would feel like you have, a PhD sitting next to you, but it's not a PhD you have next to you. It's, a system with a gigantic memory and retrieval ability, not a system that can invent solutions to new problems, which is really what a PhD is. Okay, this is
That's actually the whole deal.
It's connected to this post that Thomas Wolf made, that you inventing new things requires the type of skill and abilities that you're not going to get from LLMs. So there's a big question, which is, the investment that is being done now is not done for tomorrow. It's done for the next few years, and most of the investment, at least from the Meta side, is investment in infrastructure for inference. Okay, so let's imagine that by the end of the year, which is really the plan at Meta, we have 1 billion users of Meta AI through smart glasses, a standalone app, and whatever. You got to serve those people, and that's a lot of computation. So that's why you need, a lot of investment in infrastructure to be able to scale this up and, build it up over months or years. And so that, that's where most of the money is going. At least on the side of companies like Meta and Microsoft and Google and potentially Amazon. Then there is, so this is just operations, essentially. Now, is there going to be the market for 1 billion people using those things regularly, even if there is no change of paradigm? And the answer is probably yes. So, even if the revolution of the new paradigm doesn't come, within 3 years, this infrastructure is going to be used. There's very little question about that. Okay, so it's a good investment, and it takes so long to set up, data centers and all that stuff that you need to get started now and plan for, progress to be continuous, so that eventually the investment is justified. But you can't afford not to do it, right? Because that would be too much of a risk to take if you have the cash.
But let's go back to what you said. The stuff today is still deeply flawed. And there have been questions about whether it's going to be used. Now, Meta is making this consumer bet, right? The consumers want to use the AI. That makes sense. OpenAI has 400 million users of ChatGPT. Meta has 3-4 billion. I mean, basically, if you have a phone
well,
on
you have
Earth,
3 point something billion users, 600 million users of Meta AI.
Right. Okay. So more than ChatGPT.
Yeah, but but it's not used as much as ChatGPT. Right. So the users are not as intense.
As active. But basically, the idea that Meta can get to 1 billion consumer users, that seems reasonable. But the thing is, a lot of this investment has been made with the idea that this will be useful to enterprises, not just a consumer app. And there's a problem because, like we've been talking about, it's not good enough yet. You look at deep research. This is something Benedict Evans has brought up. Deep research is pretty good, but it might only get you 95% of the way there, and maybe 5% of it hallucinates. So if you have a 100-page research report and 5% of it is wrong and you don't know what 5%, that's a problem. And similarly, in enterprises today, every enterprise is trying to figure out how to make AI useful to them, generative AI useful to them, and other types of AI, but only 10% or 20% maybe of proof of concepts make it out the door into production because it's either too expensive or it's fallible. So if we are getting to the top here, what do you anticipate is going to happen with everything that has been pushed in the anticipation that it is going to get even better from here?
Well, so again, it's a question of timeline, right? When are those systems going to become sufficiently reliable and intelligent so that the deployment is made easier? But I mean, this situation you're describing, that beyond the impressive demos, actually deploying systems that are reliable is where things tend to falter in the use of computers and technologies, and particularly AI. This is not new. It's basically why we had super impressive autonomous driving demos 10 years ago, but we still don't have level 5 self-driving cars, right? It's the last mile that's really difficult, so to speak, for cars. It's the
I see what you did there,
the last few. That was not deliberate. The last few percent of reliability, which makes a system practical, and how you integrate it with sort of existing systems and blah blah blah, and how it makes users of it more efficient, if you want, or more reliable, or whatever. That's where it's difficult, and this is why if we go back several years and we look what happened with IBM Watson. Okay, so Watson was going to be the thing that IBM was going to push and generate tons of revenue by having Watson learn about medicine and then be deployed in every hospital. And it was basically a complete failure and was sold for parts, right? And cost a lot of money to IBM, including the CEO. And what happens is that actually deploying those systems in situations where they are reliable and actually help people and don't hurt the natural conservatism of the labor force. This is where things become complicated. We're seeing the same, the process we're seeing now with the difficulty of deploying AI system is not new. It's happened absolutely at all times. This is also why, some of your listeners perhaps are too young to remember this, but there was a big wave of interest in AI in the 1980s, early 1980s, around expert systems. And the hottest job in the 1980s was going to be knowledge engineer, and your job was going to be to sit next to an expert and then turn the knowledge of the expert into rules and facts that would then be fed to inference engine that would be able to kind of derive new facts and answer questions and blah, blah, blah. Big wave of interest. The Japanese government started a big program called Fifth Generation Computer. The hardware was going to be designed to actually take care of that and blah, blah, blah. Mostly a failure. There was kind of, the wave of interest kind of died in the mid-90s about this. And a few companies were successful, but basically for a narrow set of applications for which you could actually reduce human knowledge to a bunch of rules, and for which it was economically feasible to do so. But the wide-ranging impact on all of society and industry was just not there. And so that's the danger of AI all the time. The signals are clear that still LLMs with all the bells and whistles actually play an important role, if nothing else, for information retrieval. Most companies want to have some sort of internal experts that know all the internal documents so that any employee can ask any question. We have one at Meta. It's called MetaMate. It's really cool. It's very useful.
Yeah, and I'm not suggesting that that modern AI is not, or modern generative AI is not useful, or I'm asking purely that there's been a lot of money that's been invested into expecting this stuff to effectively achieve God-level capabilities. And we both are talking about how there's potentially diminishing returns here. And then what happens if there's that timeline mismatch, like you mentioned.
Yeah.
And this is the last question I'll ask about it because I feel like we have so much else to cover. But I feel like timeline mismatches, that might be personal to you. You and I first spoke 9 years ago, which is crazy now, 9 years ago, and about how in the early days you had an idea for how AI should be structured, and you couldn't even get a seat at the conferences. And then eventually, with the right amount of when the right amount of compute came around, those ideas started working, and then the entire AI field took off based off of your idea that you worked on with Bengio and Hinton, but.
And a bunch of others.
And many others. But for the sake of efficiency, we'll say go look it up. But just talking about those mismatched timelines, when there have been overhyped moments in the AI field, maybe with the expert systems that you were just talking about, and they don't pan out the way that people expect, the AI field goes into what's called AI winter.
Well, there's a backlash, yeah.
Correct. And so if we are potentially approaching this moment of mismatched timelines, do you fear that there could be another winter now, given the amount of investment, given the fact that there's going to be potentially diminishing returns with the main way of training these things? And maybe we'll add in the fact that the market the stock market looks like it's going through a bit of a downturn right now. Now, that's a variable, probably the third most important variable of what we're talking about, but it has to factor.
So, I think, there's certainly a question of timing there. But I think if we try to dig a little bit deeper, as I said before, if you think that we're going to get to human-level AI by just training on more data and scaling up LLMs, you're making a mistake. So if you're an investor and you invested in a company that told you we're going to get to human-level AI and PhD level by just training on more data and with a few tricks, I don't know if you're going to use your shirt, but that was probably not a good idea. However, there are ideas about how to go forward and have systems that are capable of doing what every intelligent animal and human are capable of doing, and that current AI systems are not capable of doing. And I'm talking about understanding the physical world, having persistent memory, and being able to reason and plan. Those are the four characteristics that need to be there. And that requires systems that can acquire common sense, that can learn from natural sensors like video as opposed to just text, just human-produced data. And that's a big challenge. I've been talking about this for many years now, and saying this is what the challenge is. This is what we have to figure out. And my group and I have, or people working with me and others who have listened to me, are making progress along this line of systems that can be trained to understand how the world works from video, for example, systems that can, use mental models of how the physical world works to plan sequences of actions to arrive at a particular goal. So we have kind of early results of this kind of systems. And there are people at DeepMind working on similar things, and there are people in various universities working on this. So the question is, when is this going to go from interesting research papers demonstrating a new capability with a new architecture to architectures at scale that are practical for a lot of applications and can find solutions to new problems without being trained to do it, etc. And it's not going to happen within the next 3 years, but it may happen with between 3 to 5 years, something like that. And that's kind of corresponds to the sort of ramp up that we see in investment. Now, whether other So that's the first thing. Now, the second thing that's important is that there's not going to be one secret magic bullet that one company or one group of people is going to invent that is going to just solve the problem. It's going to be a lot of different ideas, a lot of effort, some principles around which to base this that some people may not subscribe to and will go in a direction that is will turn out to be a dead end. So there's not going to be like a day before which there is no AGI and after which we have AGI. This is not going to be an event. It's going to be continuous conceptual ideas that, as time goes by, are going to be made bigger and to scale and going to work better. And it's not going to come from a single entity. It's going to come from the entire research community across the world. And the people who share their research are going to move faster than the ones that don't. And so if you think that there is some startup somewhere with 5 people who has discovered the secret of AGI and you should invest $5 billion in them, you're making a huge mistake.
Bueno, esto que ha dicho último es tremendo. Si apuestas o inviertes en una compañía de 5 personas que creen tener el secreto de la inteligencia artificial, estás equivocado. Me han parecido 2 charlas espectaculares. Esta última casi es un resumen muy potente del estado actual, pero pensad que las fechas son las mismas. 3-5 años, no para una AGI, sino para ir evolucionando hacia una dirección diferente y cada vez siendo las cosas mejores, ¿no? Nada distinto de lo que están proponiendo las otras compañías y empresas, ¿no? Voy a ver lo que habéis estado diciendo en el chat. Vale, que tenga nada. Bueno, difícil continuidad. Por cierto, nada. A ver, ¿qué dice este? Raúl Ávila dice: LeCun tenía razón desde el principio. Curioso que actualmente todas las empresas estén haciendo justamente lo que LeCun ya mencionó. Interacción con el entorno. Sí, van todas en esa dirección. Eso no significa que lo que se ha hecho con los modelos de lenguaje no vaya a ser útil. Pero sí, estábamos hablando de ArcGIS, de Saturn, bueno, eso sería xHUB.AI, ArcGIS, Saturn con la era de la experiencia, Demis Hassabis también poniendo en el self-improving y también en el tema del modelo del mundo, dicho por él, con palabras textuales. Bueno, vamos, no solo lo decía LeCun, lo que pasa es que LeCun ha sido muy contundente con el tema del LLM y otras técnicas. Y ahí ha sido valiente con los modelos de energía, con las técnicas que sustituyen al aprendizaje por refuerzo, otras propuestas matemáticas que no difieren totalmente de algunas de las cosas que se han hecho, otras sí. Bueno, en su charla y con todo el contenido que existe, pues bueno, sí que es cierto, ¿no? Si tú quieres investigar en inteligencia artificial general, bueno, en el LLM ya no vas a poder hacer nada, investiga en una línea distinta, ¿no? En esas piezas, en esas arquitecturas cognitivas. Todo eso irá emergiendo y apareciendo. Y bueno, lo dice en un plazo de 3-5 años. ¿Que llegará un momento que suceda un evento que esto llegará allí? No creo. ¿Que todas las compañías van a ir más o menos evolucionando a una misma velocidad? Porque dependen mucho de investigaciones o pequeños avances. Entendemos que sí. No sé, quizás nos llevamos una sorpresa, pero todo eso son elucubraciones, ¿no? Sí, me parece muy grande LeCun. A ver, y yo LeCun, bueno, viene de Meta, anti-Trump, a nivel político fue un auténtico hater contra Elon Musk. A ver, respeto absoluto, pero es un auténtico genio. Y me ganó totalmente con ese enfrentamiento con Max Tegmark cuando dijo que la inteligencia artificial no era una tecnología que pudiéramos dar a la sociedad, porque si se la hubiéramos dado a Hitler no estaríamos hablando. Y ahí quien le plantó cara defendiendo el código abierto fue Yann LeCun y la señorita Mitchell. Estas dos personas para mí tienen el respeto y el cielo ganado. Fue un momento súper tenso y quien echó, con perdón de la palabra, cojones fue la señorita Mitchell con el señor Yann LeCun, ofreciendo una visión de la inteligencia artificial diferente, positiva, constructiva y de futuro para la humanidad, no de Terminator. No de Terminator. Entonces, bueno, aunque sea Meta Zuckerberg, bueno, eso es otro tema, ¿no? Bueno, chicos, yo creo que 2 horas y cuarto, estoy un poco cansado ni he bebido. Yo creo que ha sido súper interesante en el sentido de ver una charla muy técnica con otra charla, bueno, es un trocito del podcast. Os recomiendo ver la de, primero, si vais a volver a ver la primera, pues podéis ver la de Columbia Engineering, que es la misma pero más amplia. Acordaos que están los papers de VJPA2, que yo no los he visto aún, pero están muy, muy interesantes. Y luego el clip que hemos visto es de un podcast, concretamente de Alex Kantrowitz, que la duración es de 1 hora, ¿no? Entonces ahí dirá más cosas Yann LeCun. Otro programazo de xHUB.AI. No sé si vamos a tener programa esta tarde porque estoy bastante cansado. Teníamos un análisis de un informe del Foro Económico Mundial que tiene muy buena pinta, entonces no sé si... lo que pasa es que si la semana que viene hacemos el de renta básica universal y el de Apple, meter el de Foro Económico Mundial y renta básica no. Entonces, no sé si voy a tener fuerzas. Me voy a tomar media hora de conexión con lo divino. Puede ser que haya programa, no lo sé. Si hay programa nos vemos a las 7:30. Si no, pues ya la semana que viene, porque mañana, a no ser que haya un cataclismo, no creo que hayan programas. Aprovecharemos para recuperar el ritmo de los podcasts, la publicación de los podcasts, que estamos con retrasos. Muchas gracias por estar ahí, una gran audiencia, a pesar de ser a las 3. Un abrazo y nos vemos o esta tarde o a la próxima.